The sun warms the building, and heat enters through the roof, walls, windows, and doors, making the indoor spaces hotter and less comfortable. A centralized cooling system is then needed to remove this heat and maintain a comfortable indoor environment. In today's session, we'll understand how a chiller removes heat from the building and transfers it to the outside, helping keep the indoor space cool and comfortable. Now, let's understand the chiller system. Whether it's a water-cooled chiller or an air-cooled chiller, both work on the vapor compression refrigeration cycle. Let's start with the compressor. The refrigerant enters the compressor as a low-pressure, low-temperature vapor. The compressor compresses it, increasing both its pressure and temperature. Now, the refrigerant leaves the compressor as a high-pressure, high-temperature vapor and moves to the condenser. Here, it transfers its heat to the condenser water flowing through the tubes. As the refrigerant loses heat, it condenses into a high-pressure liquid, while the condenser water carries the heat to the cooling tower. After that high-pressure liquid refrigerant passes through the expansion valve, as it passes through the valve, its pressure drops suddenly, which also causes its temperature to drop. It leaves the expansion valve as a low-pressure, low-temperature liquid and enters the evaporator. The evaporator is filled with refrigerant, while the chilled water flows through the tubes inside it. The chilled water is pumped to the AHUs, where it absorbs heat from the building. It then returns to the evaporator, carrying this heat. Here, the refrigerant absorbs the heat from the warm, chilled water and evaporates into a low-pressure, low-temperature vapor. This vapor then returns to the compressor, and the entire cycle keeps repeating to maintain a comfortable temperature inside the building. In a water-cooled chiller system, we mainly use two centrifugal pumps, and each one has a different job. In modern HVAC systems, centrifugal pumps are usually equipped with a variable frequency drive, or VFD. Now, what is a VFD? VFD stands for Variable Frequency Drive. It is an electronic device that controls the speed of an electric motor by changing the frequency and voltage supplied to the motor. Think of it like the accelerator pedal in a car. When you press the accelerator, the car goes faster. When you ease off, it slows down. A VFD does the same thing for an electric motor. So why do we use a VFD on a pump? A centrifugal pump does not always need to run at full speed. The cooling load in a building keeps changing throughout the day. Sometimes the demand is high, and sometimes it is low. Instead of running the pump at 100% speed all the time, the VFD automatically adjusts the motor speed based on the required water flow. Chilled water primary pump. It circulates chilled water from the chiller's evaporator to the AHUs or fan coil units. As the chilled water absorbs heat from the building, it returns to the chiller to be cooled again. This cycle continues to provide comfortable indoor cooling. The second is the condenser water pump. Its job is to circulate water through the condenser. This water absorbs heat from the hot refrigerant inside the condenser and carries that heat to the cooling tower. In the cooling tower, the heat is released into the atmosphere, and the cooled water returns to the condenser to repeat the process. A pump pushes cold, chilled water through insulated pipes to the air handling unit, or AHU. Inside the AHU, the chilled water flows through a cooling coil. This coil is made of many copper tubes with aluminum fins to increase the heat transfer area. At the same time, the AHU fan draws warm air from the building and pushes it across the cooling coil. As the warm air passes over the cold cooling coil, air becomes colder. This heat transfer cools the air, and air handling unit supplies this cooled air back into the rooms through the duct system, creating a comfortable indoor environment. Now, let's see how air enters the AHU. An air handling unit, or AHU, usually has two air inlets. One inlet brings in fresh air from outside the building, and the other brings in return air from inside the building. You might wonder, Why don't we just recirculate all the return air? The reason is indoor air quality. As people breathe, they release carbon dioxide, CO2. If we keep recirculating the same air without adding fresh air, the CO2 level inside the building keeps increasing. High CO2 levels can make people feel tired, sleepy, and uncomfortable. That's why the AHU uses fresh air dampers and return air dampers. These dampers control how much fresh air and return air enter the AHU, maintaining good indoor air quality while also saving energy. Once inside the AHU, the fresh air and return air mix together. Since the fresh air coming from outside may contain dust, pollen, and other airborne particles, the mixed air first passes through a series of filters. It typically flows through a pre-filter, which removes larger dust particles. Then it passes through a bag filter or fine filter to capture smaller particles. In many systems, a MERV-rated filter provides even finer filtration, ensuring the air is clean before it reaches the cooling coil. After passing through all these filters, the clean air finally reaches the cooling coil, where it is cooled and supplied to the rooms through the duct system. What is a cooling tower? A cooling tower is a heat rejection device. Its job is to remove unwanted heat from the condenser water and release it into the atmosphere. How does it work? First, the condenser pump sends hot condenser water from the chiller's condenser to the cooling tower. Inside the cooling tower, this hot water is sprayed over the fill material through spray nozzles. At the same time, a fan at the top pulls fresh air through the tower. As the air passes through the falling water, a small amount of water evaporates. This evaporation removes heat from the remaining water, making it cool. The cooled water then collects in the basin at the bottom of the tower. Finally, the condenser pump sends this cool water back to the chiller's condenser, and the cycle repeats continuously. Real-life example. You could take a mug, scoop up the hot water, and pour it back into the bucket from a height. As the water falls through the air, a small amount evaporates, and the remaining water becomes slightly cooler. If you keep repeating this process while a fan blows air across the water, the bucket of water becomes cooler and cooler. There are two main types of induced draft cooling towers: cross-flow cooling towers and counterflow cooling towers. In a cross-flow cooling tower, the air moves horizontally across the falling water. In a counterflow cooling tower, the air moves upward while the water falls downward, so the air and water flow in opposite directions. A cooling tower continuously loses a small amount of water during operation. There are three main types of cooling tower water losses: evaporation loss, drift loss, and blowdown loss.